Hey there, folks. We all know JavaScript, our best friend, the one we use to write web applications, websites, web servers, even compile it to native code, or create SMTP servers, sync engines, or even operating systems, and who knows what. But being on the development side of things, we often oversee the fundamentals of its execution, and all of a sudden, everything that used to be nice and easy turns into a spaghetti. JavaScript is full of mysteries, or we might say rules that are often overlooked or just need a brush up. As you might have anticipated, in this session and a couple of follow ups, we will look into the same. So, all of you might have heard of Node.js, which is an open source and cross platform JavaScript runtime and the runtime of Node outside browsers. When we say something has a cross platform support, what we actually mean is that the results will be consistent across different CPU architectures or platforms, be it on 64-bit, 32-bit, advanced architecture. And what it actually is a JavaScript runtime, which means it's a computer program that executes JavaScript code. It's responsible for translating human readable JavaScript code into machine readable instructions that the computer's hardware can execute. Now, the thing with JavaScript is that it has multiple implementations. Unlike most programming languages that typically have one primary version, say for example Python, which usually runs on the official interpreter or binary provided by their maintainers, JavaScript, on the other hand, runs on various engines across different platforms, like SpiderMonkey, which powers the Mozilla Thunderbird and Firefox browser, or V8 engine of Google Chrome, which powers applications like Google Chrome itself, runtimes like Node.js, and of course Microsoft Edge, and even the JavaScript core, which powers applications like Safari web browser, Bun, which is another JavaScript runtime, and Apple Books and Apple Mail, and so many other apps. With that knowledge, we will now go in a little detail of how JavaScript is executed. And along our way on the surface of JavaScript execution, we will develop a so-called mental model of the same. Now, I promise that this will benefit you whether you are a beginner or a seasoned JavaScript developer. So keep your ears up. When a JavaScript program or file is executed, and of course it will require a runtime to do so, which in our case will be Node.js along this session. So when you do something like node index.js, a process at the operating system level is started. It is the same process as is created when you open any program, say Notepad, and has a proper process ID of it. When we hit enter on this, what Node.js, the JavaScript runtime we are using, does is creates a call stack. A call stack is a mechanism to keep track of what function is now to get executed. It is indeed a stack that follows the principle of LIFO, and it itself says what is the last in top of the stack is the first to get executed. Now this might give you an idea that all we need now is to make sure what is to be executed has to be at top of the stack. Now that you know what call stack is, let's move on to scope. Scope is the set of rules that determines which variables are accessible in a given part of code. At runtime, the JavaScript engine allocates memory for variables associated with their scope. To get an idea of this, let's look at an example. Consider this is the code in index.js file we just ran. When we reach the bottommost line, we see in console that the result is up, as expected. And moving to the second console, we get undefined. Why might be that? I do not expect you to know why this is undefined, and in fact, this is something we will go in detail along the way. And it should somewhat come from intuition that status is something that's defined inside the function, so it should be the only one to use it. Anyways, we will look into this detail. I just want you to remember this. So it's easy stuff. One type of scope is global scope. Global scope contains not only explicitly declared global variables like I'm showing you, but also built-in JavaScript objects, functions, and environment-specific APIs that are available throughout the program. What can the other scope be? Right now, it's of the function, but if you truly think about this, whatever will get executed will create its own scope, like we saw in case of function. They try to keep things to themselves. So whatever that is, for sure, it needs its own some amount of memory and some set of instructions. And this, my friends, is what we call a thread of execution or the execution context. Now let's have a look at what our current mental model looks like. So we have a call stack, thread of execution, and global scope. Let's take an example similar to the previous one we just looked at and see how everything works under the hood. Now, before we move on, I want you to keep in mind or take a photograph of this piece of code so that you don't get lost along the way. Now, it is the default behavior of JavaScript to move all declarations to the top of the current scope, which you all may know as hoisting. We will shortly go into this why these num and a are undefined at first. But first, let's continue with the execution. So after this piece of code gets executed, it's only then the variables get updated to their rightful values. Now in JavaScript, a function is actually called when it has these pair of parentheses in front of it. Upon calling this function, it will get put onto the call stack. And remember what I said about the call stack, whatever is at the top of it gets executed immediately. And this is what single thread behavior means. It means the execution of JavaScript itself is single threaded. Though there are ways to do concurrent and parallel processing, but that does go beyond the scope of this talk. So this get status function will now go to the thread of execution. And like I said before, the thread of execution consists of two main things, local memory and the set of instructions to run. That is the body of the function here. Now it will grab the body of function from the global scope, and as far the hoisting is considered, unlike before, the value of status is not hoisted to undefined. This behavior will be same if let was in place of const. I want you to observe that var and const have some different behavior here. Now upon the execution of this function, what will be the result of first line? Let's run this. It's showing cannot assess status before initialization. But what about hoisting? We were promised that status is hoisted all to the top. So why the SS error? The first thing that should come from intuition is that hoisting is not broken. At the point the error was thrown by our program knows status is something, that's why it knows it's uninitialized, as the error message says it. Now this happens because hoisting works differently on for different kind of declarations. So let's deviate a bit from the talk and talk about hoisting for a moment. Hoisting shows different behavior for different declarations, some of which include const declarations, let declarations, var declarations, function declarations. So let's get into this. Starting with let and const, they fall into the same category called value hoisting or lexical hoisting. So in lexical hoisting, the portion of code or scope declared before the execution of declaration falls in temporal dead zone with respect to the declaration, which here is a in our case. So in the temporal dead zone, value of declaration cannot be assessed, hence the reference error you are seeing here. Now it comes given that execution will get terminated at this point. But if the other part was to be executed without this line and our execution passes the declaration, when we reach the second console log statement, we see the result 3 in console as expected. Now to test your skills, tell me what will get logged down here. So let's see. It turns out we neither have 1 or 2, but a reference error. This is because in the block, the console.log is right now X cannot be accessed as the execution of its declaration is yet to happen in that scope. Remember, it's lexical hoisting we are talking about. And note that the block codes in JavaScript do create a nested scope. Now when it comes to var, the portion that was temporal dead zone for let and const is the portion where the value of our var declaration remains undefined. This is called declaration hoisting, which justifies the log we are seeing in console and why in our code example before the variables were initially undefined at top. Now moving on with the execution, we get 3 in the console as expected. Another thing to note here is that var declarations are not scoped to blocks. In other words, blocks don't prevent the scope of var to go up in the chain, which means something like this will totally work. When it comes to functions, functions are a bit tricky because they can be created in different ways. Function expressions that are often anonymous can be used as callbacks. Immediately invoked function expressions assigned to variables using var, let, const, anonymous functions named and anonymous function expressions and function declarations. That was a lot. Among all, functions made using the following 4 notations using function keyword, using async with function keyword, using generator function signature, using async with generator function signature get hoisted as it is. I will demonstrate an example for the function keyword declaration to make sure you understand it clearly. So this is how our function declaration looks like. We have declared a function with the function keyword and called it 2 times. One before the execution of its declaration and one after the execution of its declaration. So let's move on with the execution. As you can see in the console, we get the log as expected, which implies when we call it before the execution of its declaration, because of hoisting, we were able to use this function anywhere we want, even somewhere what would have been a temporal dead zone in case of let and const. Now moving on with the execution, the second log statement is as expected. Now I hope the concept of hoisting and functions is clear in your heads. So let's go back to the execution context of our getStatus function. Now you know why we were getting this error of initialization, because we were using status in its temporal dead zone. Let's just say this line was not in our code. The execution will then continue and will pass the execution of declaration of the status variable. Now you can see that we have the status variable in our local memory with the value of up some string after concatenation with the value of a from global scope. The fact that it was able to access the value of a from its outermost scope is what is known as scope chaining in JavaScript. So after hitting the return statement, the getStatus function execution gets completed. The value up some string is returned back to the point where the function was called, in this case to the console.log statement. At this point, the execution context of getStatus is destroyed and the garbage collector of V8 engine will reclaim the unused memory in its garbage collection rounds. Now our execution is back to the console.log function, and remember, I said that every function that needs to be executed will first go to the call stack. Console.log remains no exception. After all, console.log in itself is a function which in Node.js has the default behavior to stream the data passed to it to the standard output, which here in our case is console. The reason I skipped this till now is we were not aware of it till now. And in future, it comes given that console.log will also go to the call stack and have its place in the thread of execution, and only then it will show something on standard output. After this gets executed and execution context is destroyed, we see in console up some string. Now the execution will go on for another console log statement in the same way, which will print undefined because the value of status got destroyed along with the execution context where it was defined, and we have no reference to its value. At last, we will get some string as it is in the console because A is right here in the current scope. Now I hope that your understanding related to how execution takes place is clear to some extent. This video barely even touched the surface of how execution is carried out. There are other JavaScript concepts too that require understanding, such as closures, which will be the next follow up video after this. Meanwhile, let me know what your thoughts are about this and stay tuned for upcoming write ups and videos. Thank you for your time.